Alright, so question number 3 asks you, for each of the 20 amino acids, specify whether or not they are S or R at the alpha carbon. Alright, so let's draw a typical amino acid. So we have our NH3, and the projection I taught to you guys is the one shown here. Right. Now, this is a Fisher projection, so the bonds going out to the top and bottom are dashes. The sideways ones are coming out of the board or out of the screen at you. All right. Now, so basically, if you can mentally vision this, I wish I could draw, kind of rotate this in three-dimensional space. We're going to be rotating this whole molecule forward here because we want the hydrogen to be in the back. Now, in most of our amino acids, I'm just going to put a CH group here. So most of our amino acids have the CH group here at this position. All right, so when we rotate this forward, all right, what we're going to be seeing is our central alpha carbon with the hydrogen behind it. So I'm going to draw that as kind of a little dash thing here. That's the hydrogen behind it. So this is our central alpha carbon, the hydrogen back behind it. And going up to the top is our CH, R side chain. And over here we'll have the COO minus, and on this side the NH3 plus. All right, so prioritizing the groups. All right, so we always prioritized groups in order of molecular weight. So the nitrogen here is the highest priority because it's heavier than either of the two carbons. All right, now in our second case, we have two carbons, the COO or the CHR. So we look at the next thing that's attached to it. All right, in this case, for almost all the amino acids, all right, the COO is going to be our second highest priority group. All right, and then this will be third. So for most of our amino acids, the rotation is going counterclockwise like this, which will be the S configuration. Now, there's two exceptions to this. All right, one is glycine. So it's glycine. The alpha carbon is not chiral at all because we have two hydrogens bound to it, two identical groups. All right, now the one exception to this, the other exception, is going to be the amino acid cysteine. So in cysteine, the nitrogen is still the highest priority group. And then the other two groups, we again have hydrogen or carbons there. All right, so we want to look at what is attached to those two carbons. Well, in the case of cysteine, we have a sulfur that is attached to those carbons, which is a higher priority group than the oxygens of the carboxylate. So now this is the second highest priority, and the carboxylate is the third. So our rotation now goes clockwise. And so for cysteine, this is the one amino acid where the L amino acid form of cysteine is R at the alpha carbon. All the other 18 L amino acids, they're going to be S configuration of the alpha carbon, and then glycine is achiral.